Well, welcome to our today lecture. Let me share the screen then now. Screen is being shared. And I'm going to turn off my webcam, so we'll focus only on the lecture. I guess you guys saw enough of me. Okay, so let's see. Last day, we talked about planetary gears, and we said this is one of amazing invention. You can transfer torque or speed and convert it to a large torque or large, let's say, speed, if you want, depend on your design. We talk about its component, and we get to the point to analyze the motion of gear trains for planetary gear trains. So one trick that we are going to use, which I explained here before getting to the planetary gear for a very simple case, is to use a relative motion. Just to refresh your mind, so we know if C is fixed, this is just a simple system. So everybody knows omega 2 over omega 3 is going to be N3 over N2, and we know the minus because of change in direction. So we can translate the same things, saying that we can calculate everything with respect to C. So omega 2 with respect to C and omega 3 with respect to C. It has the same meaning as if that we are fixing the carrier C, okay, when we write this sentence. So if that's the case, then it is still minus N3 over N2, but the left-hand side has a different meaning because it's a relative motion, and we know C is not in fact fixed. We have to write omega 2 minus omega C and omega 3 minus omega C, right? And we said that this is actually came from the idea that we had in the past when we say velocity of A with respect to B, it means VA minus VB. Or when we say omega A with respect to B, let's say when two parts are rotating with respect to each other, it means omega A minus omega B. And still they are vectors, right? The vector that come out of the screen. Let's say if I have one rigid body here, one rigid body here, this is A, this is B, and each of them is rotating omega A, let's say omega B. The relative speed when I say omega, so this is B. When I say omega A with respect to B, it means that I'm standing on top of this. So it means that B is not doing anything. I'm standing on it and I'm just looking at A. Okay, so that's the idea. So with that, if I want to solve the problem at the top, right? The one that we see at the top. So how we can proceed with that? So let's assume that we are fixing C. Okay? If C is the reference. Or in other words, assume or imagine, assume maybe is not the right word, imagine C is fixed. So you hold it with your hand. Okay, so you know how to write, for example, omega S, instead of numbers here, we just use letters. But always we use numbers for gears, but here just to convey our message. So I can write down omega S now with respect to C to translate what I said over here. And omega, for example, R with respect to C. Okay, I can write it down like that. Or if I'm interested in knowing something about gear P, the planet, I can write down, for example, let's say S with respect to C, R with respect to C, let's write down it. We have the freedom. We can use S or R, omega S with respect to C, omega P with respect to C. Okay, so, and now this sentence, you can think of C being fixed. So C is fixed, right? If C is fixed, of course, if it's difficult for you to visualize it, imagine that now, because C is fixed, it's a link that we can even cut and remove this part. Okay? Or on the picture on the left, imagine that with your hand, you hold C. If you hold C, now this point is fixed. This point is fixed, right? And it's no longer a planetary gear. And we know how to solve it. Okay, let's solve the first one. If we have this setup, meaning that C is being fixed, what is omega S to omega R? So we know it's going to be minus NR over NS, right? Because it's a, look, if it's difficult to look at the right picture, look at the left picture. It's a simple system and P is going to be redundant, right? We can get rid of P. We can write it down like omega S with omega P, give me minus NP NS, and then omega P, omega R, give me plus NR NP. Multiply them, you will get that. Get rid of NP and you're going to have NR over NS with a minus sign. So what about omega S with P? Is going to be minus NP NS. Right? Because it's just a simple system. And the left-hand side, we will translate it now to what we know from for a relative motion. So it's going to be omega S minus omega C divided omega R minus omega C equal to NR NS. And this guy will be omega S minus omega C omega P minus omega C equal to minus NP NS. And please do not consider this as formula, because with gears, each problem is going to be different. So we don't have any fixed equations. All right, so you will see, we're going to solve in a moment 2 examples, and you will see each problem is different. You just need to know the concept, how to solve the problem. And the trick, as I showed here, is as simple as that. You just visualize that C is being fixed, so you calculate everything with respect to carrier C. And this is, in fact, the simplest way to explain and solve this problem. Maybe in your textbook or different resources, you will see different solutions, but I found those more confusing. And a student usually give up on this topic and say, okay, I'm just going to skip this for my exam, which is a mistake because they think it's complicated. But with this method, it seems very simple. The way that I explain it, I hope you guys could follow and it's easy for you. And of course, it requires your previous knowledge for knowing the system, the simple system and other systems. The compound system. Is there any question here before I solve any example? Are we good? Okay, so if it is good, let's see it in action. In one example, we'll solve one example together. So let's read this example together. and then visualize the motion and see what's going on here. So it says C is a carrier. Okay, we know and we can see it. And we have gear 5 is driven, right, clockwise at 150 and 50 RPM. So we have then omega C. This is the information that we have. So we have omega C 150 and omega 5 50 RPM. It says when we view them from the right side. So we'll stick with viewing from the right side. This is my eyes looking at it. And I can make an assumption here. Let's be consistent with the past. Since it is clockwise, we can have negative sign here because they are clockwise, right? CW, CW. So that's the information we have. And we stick with this notation that that clockwise is mean negative. So we want to find out omega 2 and its direction. Is it positive or negative? So C is the carrier, right? And as I said, you can visualize that you assume it's being fixed. So you write down omega 2 with respect to C, omega 5 with respect to C is equal to omega 2 minus omega C, omega 5 minus omega C. All right, that's one side. Other side, when we see omega 2 with respect to C, it means now you fix C. And I want you guys to write down for me what is omega 2 with respect to omega 5 if C is being fixed, if it is just a simple case. And you can visualize that this guy is no longer there. And because we claim C is being fixed, it means this bearing is now fixed, right? So 2 is rotating. 2 is rotating. As a result, 3 and 4 are rotating, and then it results to 5. And 3 and 4, they are on one shaft and they are fixed. They are not rotating around the sun or whatever, the main axis. And you should be able to write down. And you can write it in the chat if you manage to write this relation. So for this system, you're looking after finding omega 2 with respect to omega 5. And it is a compound system, right? For a compound system. And it is if C is fixed. Tell me what number you will get. You have 30 seconds and you can type it in the chat. We want to get from omega 2 to omega 5 for this simple system. So we have one answer, N5 over N2. Let's see what others will get. Do not rush it, right? Always write down how you get from 2 to 5. So first write 2 to 3, and then 4 to 5, and then you'll see if something is redundant and it's going to cancel out or no. So I suggest do not rush it and write down everything. So another answer, Kihomi, N3 N5, N4 N2. Okay, that's a good answer from Kihomi. What else? Do you guys agree? So Wasif got the same answer. And Achilles realized that the mistake that he did. Okay, good. So almost you guys got it, right? So you write down one and you guys were correct. You write down the relation for these two, which is going to be minus, like, as I said, do not rush it. I have a tendency to rush it, but it's not a good strategy. So if we just write down omega 2 is rotating omega 3, and this is their relation. And then 3 is getting to 4, and they are similar and they are positive. And then 4 transfer its motion to 5, change in direction, and 5 and 4. And then you multiply all of these guys together and do the math. So simply omega 2 over omega 5, you will get minus minus cancel, n2 and 4, sorry, n3 and 5, n2 and 4. A quick sanity check. I have omega 2 over here, right? And then on denominator, I have n2 and 4, like the even numbers. Then omega 5 here, then I have n3 and 5. Just a quick sanity check at the end, but always is not correct because sometimes the numbering in a question might be different. So that's it then. N3, N5, N2, N4. Let's substitute these numbers. Okay, so and let me move all of these guys here down here. This is our side calculation. So what is omega 2? It's the question. It's the unknown. What is omega c? Is and omega 5 minus 50 plus 150. You see, I put all the signs there. And N2, 18, sorry, N3, 30, and N5, 20, N2, 18, and the other guy is 28. So from here, we will find omega 2. Let's just quickly find it and see what is the sum. I'll get my calculator. And you guys please do the same. So making sure that I didn't make a mistake. So 20 multiplied by 30 divided by 18 divided by 28. And then multiplying everything's by 100. And then minus everything's 150 gives me minus 31 RPM or 30 almost. It's okay to round the numbers that you get at the end by plus minus 1. Okay, that's with the gears. So please check my calculation and to make sure that I haven't done a mistake. And again, rounding plus minus 1 is okay in your exam or in future, because always with gears, there is this plus minus or plus minus 2 RPM. So let's say rounding in a range of plus minus 1 is okay. So if, for example, somebody wrote minus 31 for this, it is a correct answer. If somebody in the exam write 30.95, it is still acceptable. However, in future, in your work, if you write down 30 plus 95, it means your system is so accurate that the rotation is going to be, the accuracy of rotation is going to be in a range of 5%, not 5%, sorry, 0.5 or 0.05. And unless it is one of those gears in switch watches, right? Super expensive gears, then you can claim that. With regular gears, plus minus one, it's actually, it's correct. And in your exam or in your future, it also asks for the direction. So if it is minus, it means it is clockwise. So it means when I'm looking, like my eyes is here, right? So according to what the question said that, carrier is rotating clockwise. Clockwise means like that. And 5 also rotating clockwise, is rotating like that. And we found that 2 also is rotating clockwise. Okay, this is the rotation. So this is omega 2, this is omega c, and this is omega 5. And again, keep in mind, this is all viewing them from one direction. Super easy, right? I don't know why students think it is. It's not an easy topic. Or maybe because I'm not their teacher. I guess I will see you guys again next year for 360, if you are lucky. You may say, now I'm bragging, right? So I guess 360, I will be teaching 360, but there might be 2 sections. So I might be teacher in one of those. I don't know yet, but if that, we will see each other. All right, any question for this? Let me quickly stop and check chat. See if there is anything there. Nothing. Good. All right, so I'm just going to give you a minute to write down if any note or anything. And also return back that guy, right? The C is there still. And example 6. And I expect you guys to be able to solve this one. It's one step more difficult than previous one, but the same concept. You just need to visualize that C is being fixed and you have a simple system. Now solve it. But first, read the question and try to understand what's going on. And as you can see, we don't need to exactly know which one is planet, which one is a ring. Like previous one didn't have a ring. This one has a ring, but who cares? We just use the numbers, we'll find the values. This ring and planet, and this is just the terms at the beginning, so you guys become familiar with the topic. All right, so you have a couple of minutes to think about it, and then we'll solve it together so you guys could compare. I'll do the same. So it says omega 2 is 60 RPM. And it is positive, right? So there are some extra information. Of course, we know gears has to mesh to each other. We want to find out omega 5. So that's the question. But again, please try to visualize the motion of these gears, this system. Okay? Look at 6. 6 is an internal gears, right? It's a large gear. In this picture, we just show the like the cross section of these gears. And this carrier is rotating 3 and 4 around this 5. And the ring is being fixed. See, this is the sign that tells us that the ring is being fixed. Ring is fixed. And again, keep in mind in a planetary gear, as that video last day I told you to watch, sometimes depends, we can fix the ring, we can fix the sun, the planet, so it depends. And usually in question, we show it by this sign. Now I give you 1 minute to carefully think about it. All right. Let's see. Okay, I'm guessing most of you started with like this omega 2 with respect to C and omega 5 with respect to C, right? Probably you start from there. And the left-hand side will be omega 2 minus omega C, omega 5 minus omega C. And this side, how do we get from 2 to 5? Similar to the previous problem, right? I'll write it down here. Two is rotating 3 and 3 and 2, and 3 and 4 are the same because they are on the same shaft, and 4 because our aim is to get to 5, right? And then 4 is rotating 5. 4 in fact is doing 2 jobs, is rotating 5 and also the ring. So, but we don't care about it now because we just need to get to 5, and it is n5 divided by n4. So from here, I will get omega 2, omega 5, n3, n5, n2, n4, and it is positive, right? So this is if C is fixed. Okay, so let's write it down here. So this is positive n3, n4. Oh, I made a mistake here. This is N3 and 5. So N3 and 5, N2 and 4. Everybody agrees with this? No mistake? Are we good? Okay, so this is good, but it cannot solve the problem for us, right? Let's substitute the values. I know omega 2, so 60 minus omega c. Omega 5 is unknown, minus omega c. We have N3, N5, N2, and this is positive. 2 unknown. What should we do? Any idea? Give it some thought and see what should we do, because we are stuck here, right? That's okay, you can guess anything. Okay, let's see. So Wasif says, can we solve for N5 first? Omega 5. How? How should we solve for omega 5 first? So I will give you a hint. What is omega 6? It's 0, right? It's fixed. That's our savior. It's going to save our life here. Because we have another piece of information. 6 is being fixed. So we treat it as a gear, and we know it's omega, it's 0. Now we can do anything that we want, right? So I will write the same relation that I wrote about omega 2 with respect to c, or I can solve with 5, that's the same. So I will show you both. Omega 2 with respect to c, omega 6 with respect to c, right? So this side then will be omega 2 minus omega c. Omega 6 minus omega c is equal, except now this guy is 0. And this side, simply, if we follow the rules that we had, it's going to be N3 and 5. No, sorry, let's solve it there. Just want to guess it, but we'd better be patient and solve it. So omega 2 is rotating omega 3, and it is minus N3 and 2. Then 3 is attached to 4, and then 4 is rotating 6. Omega 4, omega 6 is plus, right? They are not going to change direction because we have internal here, and 6 and 4. So if we simplify that guy, we'll get minus sign here, and it will be N3, N6, N2, and 4. So 2 equations, 2 unknown. So N3 is 30, N6, 76, and N2, 18, N4, 28. Don't forget the minus sign here, right? So omega 2 minus omega C minus omega C. So we will find omega C from this guy and then omega 5 from there. So this is method 1. Okay, sorry. So this is method 1. Method 2, somebody used 6, but we'll write, let's say 5 and 6. So omega 5 with respect to C, omega 6 with respect to C. Okay, so it will give us, let me move it a little bit there. So it's good to also know the method 2. So in the exam, when you solve problem, this is all equal, give you the same answer. So this side, we know it means for us omega 5 minus omega C, and then omega 6 minus omega C, and we know this guy is 0. And this side for us, so 5 is rotating 4 and 4 is rotating 6, right? I want you to focus on this section. And see how we can get from 5 to 6. So omega 5, and again, please be patient. Do not rush it because it's simple if you don't rush it. So simply 5 is rotating 4, and we know omega 5 over omega 4 is minus N4, N5. And then 4 is rotating 6, and they are plus because we have one internal gear, right? No change in direction. And it's going to be N6, N4. Multiply them, you will get rid of N4. So that's the redundant because, and you can see why, because it's a simple system. They're all in one plane. 4, 5, and 6, they are in one plane. But even if you don't know it, just writing the math will tell you. So omega 5 over omega 6 will be N6 N5 with a minus sign, right? So you substitute your values, and now you have 2 equations, 2 unknown. This is method 2. So from here, we have, let's quickly finish it and we are done. So omega 5 is unknown, omega C is unknown. And this is minus N6, 76, and N5, 20. Right, in method 2, now you have equation 1 and equation 2. 1 and 2 solve together. you will find omega c and omega phi. Please try both methods and you will see you will find the same answers, right? And both are correct, equally correct. Of course, the method 2 is a little more headache, right? Because method 1 seems that gives you a straight omega c and then you're done. When you solve with 2 methods, again, you might get a little plus minus 0 point something, which is okay with gears. I give you 10, 30 seconds to again review and see when a very complex problem like this, now it's super simple, right? Now you can show off to a mecha student that these things are simple for you, because probably these sort of problems will be challenging for them if they haven't learned it this way. So one more time, the trick again is to see what information you have in this system. And you saw in this system, we are stuck. But when we notice that 6 is fixed and we have some information related to 6, then the problem was solved. But we need to write 2 equations. We cannot solve it like previous one in one shot. So this one gives me omega c, and this one gives me omega phi. And please, in your exam, do not write like me, messy here. Everything's around. Now, because I want to teach you, I just wrote here, and I have limited space here, because I wanted to put everything in one slide. In your exam, start linearly. Write down everything one after another. So when your TA or myself, we're marking you, so we can follow the logical way that you solve the problem, okay, in a logical order. Like here, if you saw me, this is here, is because we wanted to talk about this scenario. This is here because we wanted to talk about this scenario. So this is all cloud to solve extra information. All right, this is extra topic to study on your own. You can Google them, you can probably find videos, but it's good to know that gears do not have to be circular. It can be like a square shape like this, and it works. Somebody built these things. It wasn't me, and it works. And so you can see the distance between this center to center is going to stay the same, the way that we oriented that. But nobody really make gears this shape unless there is a particular application, which I don't know anything. But it's cool, right? You can maybe 3D print one, and then you see it works. So to prove other wrongs, because in an interview, maybe if I'm interviewing you, maybe I ask a question, do the gear has to be circular? And 99% of the time, people say yes. There is no way that the gear not being a circular. And then the second topic is differential. Differential, essential part in a car. And it's amazing how it works, because in a car, when we are turning left or right, the speed for our tire on the left and right, they are not the same, right? Because each of them is on a different circle. And this is where a differential comes to play. Watch this link in this video. And it's cool, in fact, to know. It's a little complicated, but it's cool to know. And this is extra topic, not in exam, not in your exam. So there are another topic that we haven't covered, and it was balancing. Balancing also topic. which is a very simple topic you can study on your own. It's not really a big deal, and it's not going to be in your exam. So the whole idea is, let's say if you have a disc, or maybe let's say imagine your car tire, right? If the center of this tire is perfectly at the center of mass is at the center, then you are good to go. But in practice, sometimes things deform, like the tire ring deform, and the center of mass might be somewhere else. Of course, not that far away. So we know when these things are rotating, with the knowledge that you have now, they are going to create a centrifugal force, right? mr omega square. To balance that, we will put an extra mass here, m prime, to cancel that out. But depends, of course, where we need to put it. This distance is e. And then you decide for an x here and m prime x omega square. So this is what people do for balancing. I remember you solved one example. It was in your practice relating to this, and it goes in topic of balancing. But it's super simple, and I just ignore it. Differential is complicated. Just try to understand it. You don't need to really go depth, unless in future you're designing differential. Okay, with that, this is our end of lecture. And I can stay in a room for a couple of minutes. If you guys have any question, I will post all the notes from Gears and including the lecture today videos. Right. So let me save this before I forget, and I will post it right after the lecture so you have access to it.
Hi, Professor. I have a quick question.
Go ahead.
I was wondering if you have like solutions to some of the past quizzes that we've written, so that we could just kind of use that to study before the exam.
Sure. Is there anyone that I haven't posted a solution? I guess the last one was on Gears, right? Okay, yeah, I haven't marked or posted the solution. I'll do that.
I know you did like a video for quiz 8, but I can't find the solutions for any of them from quiz 5 on.
Okay.
But I might be.
Yeah, I will check and I will go over all the quizzes, and if there is anything left, I will post the solution definitely. The last problem set, which is problem set 8 or 9, I don't know, on Gears, it's from your textbook, which it doesn't have the solution manual. And there are many questions, but most of them are very simple. If there is any particular one that you want me to solve, just let me know and I post the solution.
Okay, thank you.
All right, no problem. And on Monday also, if anything left that I forgot, please let me know and we'll go over it. Okay. All right. So see you guys later.